Hello, everybody. I'm glad to welcome you at Ketos Educational Platform. And today we will be discussing about our C++ developer course on open lesson, and we will discuss such topic as zero overhead principle. I think one of my favorites principle in C++ language, and I hope I'll try to share my view of this basis of C++ language and why it is so popular in different areas. My name is Pavel Filonov. I will be your lecturer for today. So I am glad to welcome you today. And let's start with just some technical check. I'd like to find out if everything is okay, if you hear me well, if you see me well, if you see right now the stream and my slides, please chat the plus sign in the chat. Oh, yeah, I see it. If there's some issues with audio or video or slide sharing, please use also the chat and share some problems and issues with me. It's also the possibility for me to check the latency, what we have right now, and I think it's almost zero latency as a zero overhead principle. And a few words about myself. Right now, I'm working as independent consultant for different companies, but my previous experience was working in information security companies, and I was involved in product development of large-scale system. Mainly was based on C++ language with high throughput and a lot of different instructions. Right now, I am instructor for C++ developer course at Ketos and also on different courses based on machine learning. But today we will be mainly speaking about C++ language and his design principle here. Let me suggest the plan for our today's webinar. At the beginning, I just spent a few minutes saying words, intro words about Ketos educational platform. After it, we will dive deeper into the main idea. What is zero overhead principle in C++? How it can be formulated? What benchmarks can we write down on different languages, which helps us to understand how we can measure and see in action. At the second part of our open lesson, I share with you information about our C++ developer course, about our team, about our learning program, and try to highlight, I think, main important advantages of our way to teach people to use C++ in the right way. At the end, I suggest maybe just by a few questions to improve your skills and knowledges about the topic of today's lessons, and I also will be glad to answer your questions during actually the open lessons and also at the end. So I'm really interested in our today's audience. So if you would like, please share with me with using the YouTube chat. Who are you? What is your IT work experience? What is your main goals? Maybe visiting today's open lessons, or you considering joining our C++ developer class. I will see your answers in the chat, so please feel free to share with me and the course team. It will be very important information for us. And also, because right now we have this online mode, it's I hope some people will see it in a recording, but I see we have the online audience right now. Please feel free to ask any questions using the chat right after these questions get into your mind. I will find some good time points during my lessons to read your answers and to answer them. Not just at the end of this lesson, but maybe during all of it. So a little bit about Ketos educational platform. I think the main words I want to say, it's all courses right now, all courses what are presented on platform mainly focused not on the beginners of IT developers of different programming languages. Our courses are focused on the programmers who already have the experience, actually. They already knew about programming languages, basic programming patterns and techniques, and we just want to find out how they can improve their skills by learning from professional experience, by learning from practice, and also discussing the advanced topics in the languages and technologies. That's why I think our main potential clients, it's not just the juniors or beginners, but maybe the middle and senior developers who maybe want to see what happens in different programming languages, or they want to improve their own area of responsibility by learning from the experience of different kinds. And our main mission is to bring the needs and expectations for enterprise. That's why our course are not maybe with academic fluent. It mainly will be focused on day-by-day practice, day-by-day best practice from the practical developer, and they will share not the knowledge from the books, just like academic approach, but I hope, for example, in our teams, our main target is to share the best practices we are using in our everyday basis. That's why maybe mainly we will be focused not on the language features. Yeah, language features are really important ones. But as you maybe already knew, if you are familiar with C++, it's also a lot of issues with tooling, a lot of interesting design patterns which can be implemented in C++, integration with different technologies, for example, how it's the easiest way to integrate with database management system from C++ code and so on. That's, I think, our main focus is not just reproduce the book knowledges in academical style, but to share our day-by-day practice experience with you. And that's why we have the different programming approaches. Yeah, we also have approaches which will be focused on junior, but for example, our C++ developer course, I think the main advantages can be get from it if you are already the practicing C++ developer, the middle or even the senior one. And if you're already familiar with Ketos educational platform, and maybe you're already familiar with different courses, please share what option will be close to you. Maybe you're just new at Ketos and it's the first time when you hear about it, or you're maybe already familiar, or even maybe already took part in some of our courses. Please share your opinion, your option in the chat. And after this few minute introduction about the Ketos, let me go deeper into this idea of C++, zero overhead principle. And let's start with this link to, I think, the really interesting interview with Lex Friedman and Bjarne Stroustrup. Bjarne Stroustrup, the creator of the C++ language, it's on the right, and Lex Friedman is well-known interviewer on the left. And it's, I think it's about 3-hour interview, actually. They discuss a lot of different topics about C++ history, its evolution, even its possible nearest future. And one of topic, which was also presented as a short part of this interview, is the discussion about zero overhead principle. What it is, what this principle means, how it can be formulated, for example, by Bjarne. The formulation really simple, and it depends on 2 theses. First one, you don't pay for what you don't use. It means what in C++ you have really a lot different possibilities, language features, but if you don't use them in your code, This mainly means you don't pay. What don't you pay? Mainly, we will be speaking about our programming performance of our code, performance in time, for example. And the second part is what do you use? It's just as efficient as what you could reasonably write by hand. It means what when you are considering maybe write some replacement for some element of standard library or maybe third-party library, which also following this zero overhead principle, you should really consider it, because maybe if you write it by your hand, you will get worse performance than it will be just the standard library. And maybe you will achieve some improvements, for example, on your CPU, on your architecture, maybe on your hardware. But the one important element of C++ code is it's cross-platform. So when you will try to apply the same techniques, for example, for different CPU architectures, you may achieve the worst performance than, for example, use something from the standard library. Yes, this principle can be easily formulated in these 2 points, these 2 bullets. But how we can find out what it means in practice, how we can measure it and see it, what examples of source code can we write down and speak about them, what they follow this zero overhead principle, and also why it is so important. I think the importance of this in C++ depends on this idea what the C++ is one of the best languages for high performance computing, for really good performance from the CPU and so on. This can be even proved by this interesting project, the benchmark game. The author of this project present some problems, which usually the CPU-bound problems, which can be solved by algorithm in different languages. And the contributors from all over the world present the solutions using the best languages, and this framework compares different elements like the execution time, memory consumption, the source code length even, and they I think once a month update the results and try to compare. For example, this picture is a comparison of time performance of different languages for different problems. It's not a single problem. I think it's 5 or 7 different CPU-bound problems, and try to arrange these different languages by the multiplication coefficient. Usually at the top 1, top 2, top 3, there are usually such languages as C, C++. And it's a really interesting thing because almost every performance improving techniques, which, for example, I knew, will be suitable for both the C and C++. After that, we see the Rust, well-known possible place replacement for C++, and after Rust, all other languages with managed memory and so on. And at the end, we see that just the Java and Lisp and the different ones, and they measure as the x times slower than the best. The best here is the C, actually. And we can ask the question, why, for a lot of years, actually, the C and C++ are the top solutions for these benchmark games. What the design principle of those language allows them to took this place and not to share it with anyone else. Maybe in some possible future, Rust will also join this top 1 sometimes or top 2, but usually it's the C and C++. And I think the one part of the answer will be the zero overhead principle we will be discussing for today. And let's try to find out how we can show this principle in action. What code can we write and consider about, does it follow zero overhead principle or not? Is it guaranteed by any compiler and any C++ dialect or not? And here I want to highlight this interesting talk from actually not from the C++ conference, but from the Rust conference, which named Zero Cost Abstractions. And the main idea of the author of this talk was to show some kind of analog in Rust word, which the author calls zero cost abstractions here. And this open lessons was inspired actually by this talk. My main contribution to it was the following. I took the examples of benchmarks from this talk and I enriched them with C++ solution and tried to follow the same techniques and same ideas during the discussion about which languages follow zero overhead principle or zero cost abstractions, you may also call it, and which are not. And let's start from possible competitors and test problem. Actually, the test problem we will be measuring today is a really easy one, but it's easily can be presented in different machine learning or computer graphics or scientific research approaches. And it's mainly will be dealing with summing of vectors, two vectors, the same size, vector A and vector B. And we want to compute the sum of elements like the inner product of them, but with some restrictions. From the vector A, we want only the elements which are greater than 2. This code can be easily write down in any language, actually, but the main idea and the main interesting point of our today's lesson will be what different solutions can we propose for this problem, and how they will be different from each other from the execution time point of view. Here I also present the benchmark stand. It's a virtual machine with Ubuntu. All tests we will be dealing with single core programming for today, and the version of compilers and the virtual machines I was using to measure different languages. And today we'll be mainly focusing on comparison the C# solutions for these problems with C++. Try to find out where we can show this zero overhead principle in action. Let's start with C#. Actually, I will be sharing with you a little snippets of code. It's not really necessary for you to be experienced in C#. I think every programmer can easily read these examples. There will be a few hard examples using SIMD techniques. But the code snippets will be small enough that it's not be possible for you to read them because will be just mainly about the idea and not the elements of concrete realization. But the first approach we will be starting with in C#, let's call it the direct loop approach. I hope every programmer can read it and understand what's happened here. And actually, it solves our test problem. It sums the multiplication of vector elements, but only for elements indices, the A element from A vector is greater than 2, and we can just return the sum of it. If we took some measurements benchmark and trying to find out with different recalculations with different vectors, after that summing and calculating the mean for execution time, we can find out the following. I think it will be in microseconds. So for example, this direct loop approach in C#, if we will measure it, it will be like the 70 microseconds took to run once this function. Yeah, in some starts it could be 75, in some stars it could 68, but the main idea here will be focused on mean elements of it. But let's consider the following. We suggest such approach and we measure it and we ask our stakeholders, is it good for you? Is it good for non-functional requirements? But sometimes our stakeholders and our requirements can make their constraints. And for example, they can give us the ideas what maybe you can suggest something better, or from the different point of view, maybe the programmer who solved the problem go to some open lesson about C# and find out what actually in modern C# they have the different approaches and solving it. And the second approach will be maybe going from this empirical for loop approach with ifs and all of elements of structured programming in some like a functional style. And for example, let's consider this realization of our solution to our problem and call it iterator. And you actually see the solution for the same problem, but using the different techniques with modern C#, and actually the solution formulated in functional style. We will iterate through both of our vectors. We will filter them only if the first element of a pair is greater than 2. After that, we will select just by multiplying the elements and sum all of it. Actually, it's maybe not a bad solution from the readability point of view. Because actually, just right now, I also formulate the idea of a solution, and it's good shown by concrete line codes here. But yeah, maybe this solution is more readable than previous one. But what about execution time? Will it be the better or the worst or the same? I am also interested in your opinion here. Please provide your opinion using the chat. What you think? This solution comparing to the direct loop will be the same in speed, the worst, or even maybe the better? I will just wait for a few seconds for latency to see the answers possible. And after that, I will share my benchmark results with you, and we will find out what it will be. And let's take a look. Actually, it will be the worst, really worst. Approximately 8 times slower than our original direct loop solution. What it means actually? We write the code, but we use a lot of abstractions. We use in C#, we use the iterators, this zip iterator. We use this abstraction like the select statement on something like a database table. And under the hood, all those abstractions give us the performance penalty. And if you see such a picture, this means that the iterator library in C# and C# compiler and virtual machine doesn't follow zero overhead principle here actually, because you try to write something by your hand, and you, for example, start with this iterator solution, and compiler wasn't helpful for you. After that, you measure, you faced its really slow one, and you rewrite, for example, your code in direct loop, and you actually achieve the better solution in time by your hand, writing by your hand. Maybe the iterator approach wasn't really good enough. Maybe we should consider differing tricks on performance improvements, which suitable for C# compilers. What can it be actually here? Well, if you're dealing with such the simple loop, the first idea will be just the loop unrolling techniques. It's well-known technique for low performance tricks when, for example, you have this cycle for loop or while loop, and you have, for example, 100 iteration, and you do the simple body of that loop. The idea of loop unrolling just maybe to replace the body of some copies, but for different indices. And this means what you will execute the same number of body loop, but the iterations will be much lower, much little ones. And for example, here we see the example when we unroll each iteration by times of 4. And this means what, for example, if original loop was 100 iterations, this version will do just 25 of it. Yeah, the code looks not so nice as the direct loop or even the iterator one. But if we try this solution and measure it, will we achieve better performance, for example, comparing to direct loop solution? And the answer, actually, we will. And the interesting point here, it's maybe 3 times faster than our direct loop solution. And such example also could be the anti-example for zero overhead principle. We can write by our hands the code what will provide us better performance than the original solution, and this interesting, maybe good by readability, but bad in execution time solution using the iterators. And when we start to see such picture, we can ask it one more time. If we already improve our performance, can we do it again? What techniques can we apply to achieve the even better execution time than this direct unrolled loop? Using modern CPUs, it can be done. It can be done by using special CPU instructions. For example, AVX instruction set in modern Intel processors. Here you see a lot of code. It's ugly code, actually, because when we will dealing with AVX and different single instruction, multiple data techniques, it will be using such a thing as intrinsics. It's like the functions, but actually compiler just translate them to the machine codes. The code will be uglier, it will be bigger, it will be more hard to read, it will be significantly more hard to write, but we can actually write it. And if we measure these solutions, will be the same as, for example, for unrolled loop, or we again can show what our hand-by-hand realization can be better. Let's measure it. Let's measure it and compare it. And actually, yes, the answer is same as for previous one. By our self-made vectorization using AVX, which, for example, it's a really good idea. What you can do it in C#, for example, you can't do it in Java, because in Java you usually have this intrinsics, which will be different for different processor architectures. In C# you can, and you can achieve this 5 microsecond result. And I think it's mainly all what we can do here. Yeah, there are maybe some additional tricks, but let's us consider what C# shows already. What, starting from the simplest one, using maybe some more readable code or using some performance tricks, we can write by our hand the code what will be much better in performance than the original version. And this shows us the counterexample, anti-example for zero overhead principle. C# compiler doesn't follow it. But what about C++? Let's go back to the main topic of our open lesson, the C++, not the C#. Let's start the same looking experiment, but in C++ way. For example, direct loop really looks closer to C# realization, but just use the C++ standard library elements here. We can write it easily and measure it, for example, using Google benchmarks. And my targets for today will be not to compare, for example, C# with C++. It's not the goal of our today's lessons. But mainly we will be focusing on comparing different C++ realizations. And the first measure give us the 5 microsecond, 5.3 microsecond actually. The solution, interesting point here, the solution execution time for C++, the simplest code are the same than the C# hardest variant. And the question here will be the following. Oh, we already achieved the good performance with this simple C++ realization. What if we use the same tricks as for C#, loop unrolling, maybe using some specific instructions? Will we achieve the better results here? Let's find out. First of all, let's try to take a look on C++ iterator solution for this problem. Here I use my custom zip iterator. It takes two containers at the input and provide the iterator of pairs of element. Yeah, it's not the ideal solution here. The code is almost the same actually, but it's use this abstraction, the zip iterator. What will be the penalty? What will be the execution time here? Interesting element, but it'll be almost the same. Yeah, the bar is even slower, but actually, if we'll consider confidence interval for these measurements, I think this solution will be the same actually. And really interesting point here. We introduce this abstraction, which replace our simple loop, but somehow our compiler find out the way to produce machine code with same performance as our previous direct loop solution. So it may be interesting area for us what we can improve the readability of our code and not get this performance penalty if, for example, in this case, the C++ compiler and this zip iterator follow the zero overhead principle. We achieve the same performance, so our abstraction will be zero overhead here. Another solution, for example, let's consider actively using the C++ standard library. And we can actually represent our problem just using the transform reduce algorithm, which will take both of our containers at the input, and we can produce the result for both with summing and multiplying elements with filtering actually. From readability point of view, sometimes it's really good to use the standard algorithm library. Here, maybe it's not the bad way to solve this problem. I think it can be easily read by the programmers who are doing a lot of C++ coding. But what about this zero overhead principle? What possible performance penalty will be doing here? Actually, it will not be any penalty. The same, if we'll consider our confidence intervals, actually the solutions will be almost the same by the execution time. Also interesting point, somehow the C++ compiler and the C++ standard library find out a way to produce the machine code, almost I think a really close one to the previous solutions, which gave us the same performance. It's also show us how, for example, some parts of standard library follow this zero overhead principle here. What also can we do? It was about readability. What about this low level performance tricks? For example, let's skip the loop unrolling, go straight ahead to SIMD instructions using AVX intrinsics, which also involved the loop unrolling as the part of the solution. A lot of code, hard to read, hard to write, sometimes impossible to debug, but we can do it. In C#, results such way provide us the great boost in our performance. What will be with C++? Will we achieve something more from our CPU here? Let's measure. Measure. Only this best practice can prove what we can do for our performance improvement techniques and what are not working actually. And the interesting point here, what actually they achieve the same. With a lot of code which use processor architecture specific intrinsics, they achieve the same performance as our initial C++ version with direct loop. What it means actually? It means what C++ compilers and standard library here follow this zero overhead principle. You can introduce these abstractions. For example, for loop. You can introduce the iterator. You can even deal with standard library elements. But you will not. You will not have this performance penalty comparing to the low-level performance tricks realization. It's, I think, the good point to show how actually the zero overhead principle in C++ can be shown in action. You can write the simple code. Let's go back to our initial version. And you have some not guarantees, but the idea what if after you will compile this code with a compiler which was designed using this zero overhead principle, and in later version of C++, all possible improvements and changes will also follow it. You will achieve the same performance result as doing by hand optimization with loop unrolling and AVX intrinsics and so on. It means what sometimes we can, using C++, write even smaller portion of code with the same performance than, for example, this realization right now presented that slide. And it's a good news. It's a good news for C++ programmers because it's not a guarantee actually, but it's a good recommendation for designing the compilers, standard libraries, and third libraries. Does it mean what any C++ code you write will achieve the same result? What will be the most performant version you've ever seen? Not actually. It's what I mean by given this idea that zero overhead principle is not the guarantee, but a recommendation. For example, in C++ 20, we have this new way to interconnect our containers and algorithm. I mean the range library. The new views replacements for these pairs of iterator. And actually, we can rewrite the solution for our original problem using this range library. We will accumulate, we will use the zip iterator, we will filter out the elements and with our condition, and we will apply the transform operator, the summing after it. Actually, it's look a little bit uglier than a C# iterator realization. but follow the same ideas, the same design principle, like some kind of functional style of programming here. And you can write it using the modern compiler. And here I use the ranges not from the standard library, but from the original version from Eric Nibbler, ranges library version 3, I think. And I also try to measure it and compare it to the other results. And here we see actually what not always any C++ code or libraries, even if they are really close to standard library, follow this zero overhead principle. Here, the layers of abstraction using the ranges library actually broke the compiler optimization techniques, and it can't produce us the more efficient code. And we actually see this performance penalty here is more than, I think, 10x times. It's a really good penalty. It's not, it shouldn't be treated as you shouldn't any time use the ranges library. It only shows that you should use it accurately. Measure, and measure again. And only after you see what these additional abstractions, for example, in your problem statement, show the same result as the simple solution, it's show your possibility to improve the readability of your code. But not the guaranteed, just the recommendation. That's the interesting trick here. If you have any question, I think it's a good time point to answer it. I will take a look on chat, and please feel free to write it down. And if we are out of question, we can actually go to the second part of our open lesson and speak a little bit about our course team, and I'll try to highlight some interesting elements of our educational program for C++ developer course. So let's take a look. But before it, let's highlight the main takeaways from this zero overhead principle part. From my point of view, this principle is one of the reasons for performance code in C++. That's the why in every iteration of benchmark game reports, C and C++, we will see this solution on these languages at the top. But zero overhead principle is not a guarantee, but just a recommendation. Some library authors can follow their targets, and as for ranges example, it follow targets to maybe some functional style programming, or maybe to replace this old one, pair iterators approach. But I think in current situation, ranges library doesn't follow this zero overhead principle. And the last but not the least, you should always measure your code. Don't trust anybody. Everybody lies, like Dr. House said. Measure every time you have some ideas about the performance. Maybe you find out a way to improve the readability of your code, but will it affect the performance of it? If it's not the hot part of your program, I think it's not really important, but actually it's a C++. If you are not facing the performance problems, why you're using C++ for it? Maybe you should consider different languages where language features will, for example, maybe improve the speed of your coding, but not the speed of your programs. And after these takeaways, let me go to our course landing page and highlight some interesting elements about our C++ developer program. I hope the slides right now changed with my web browser, and we are on the Ketos.io platform and on the C++ developer course page. Actually, even at the beginning, we have the really little interest testing. This test help us to filter out what pre-requirements for students do we have, because I will try to clearly speak it again. This is not the C++ basic course. On this course, we already suggest what if you have a few years of experience in C++ programming, this will be a possible interesting course for you, because we will not start with the basics. We will start with some, for example, modern features, and after that we will go further. I will show this program elements. The second important thing, it's like our open lesson today. All our webinars are will be going in online mode. It's it will be recorded, and recordings will be could be also used by you. But our main suggestion is to visit it. Actually, it will, I think, provide the better experience, maybe to share some ideas, maybe to ask a fast question and get an answer from the lecturer, and so on. Here we can see our main entrance information. The course will start at 27th of June, and it will be twice a week on Tuesdays and Thursdays on 20 hours at this time zone. So consider it if you like to study not just by looking at the recordings, but to actively involving in discussions, asking questions, and try to learn from the real experience. It's the main ideas, what you will be actually familiar with C++. So we will try to test it in our basics. And I already take this, highlight some elements of our learning process. And what about program? Here, let's discuss our program. First of all, we will start not by the C++ basic, but the actually real practice basics. Because when, for example, you go to a new project, the first problem for you will be not to read the code, but to build it. And still, unfortunately, in C++ ecosystem, the building of large projects, the testing of testing them and deploying them, it's a really complicated issue, involving the different instruments. Mainly, we'll spoke about CMake, because the CMake is top one in all build systems and modern C++. Yeah, we knew a few more, but just by surveys, the CMake are most popular one. After we will just recap the building process, the cross builds for different compilers for different operation systems. In this first module about modern C++, we will consider different standards. Starting from the C++ 11, it means you already knew everything before C++ 11. Up to C++ 20. Maybe we will also consider even adding the additional lesson about C++ 23. Also, some important topics which are usually not in basic courses about smart pointers implementation. The allocators. Allocators is a really important topic for C++ developers, because it allows to introduce your own memory management algorithms, which are usually the simplest performance bottlenecks in different programming. And through the template magic to C++ 17 and C++ 20. After that, the interesting point, what we will be mainly not talking about the C++ in vacuum, but about C++ applying to different subdomains. For example, if we spoke about large system, which are usually programming, for example, using C++, in those systems, we need to understand how we can apply different design patterns, the gang of four design patterns, the grasp, or maybe sometimes even C++ specific design patterns, for example, which can be considered from the Boost library. This means what this mainly will be focused on object-oriented programming, but not only. And we will try to show in what situations, in what design problems, different patterns could be easily involved, and how we can how we can code them using modern C++, not the simple, but the modern C++. After the architecture model, we'll talk about parallel computing. Just a little recap about multi-threading, how it can be done in modern C++, what possible problems do we have in race conditions, deadlocks, and so on. And after this quick recap, the multi-threading patterns, elements about asynchronous programming using the modern C++ elements, a little bit about log-free data structures. Sometimes simple synchronization primitives such as mutex give us real performance penalties, and we will try to find out how we can improve our multi-threading code. And usually this means what we must dive deep into log-free programming and log-free data structures, and they usually based on the different atomic types of which I was also introduced in C++11. And when we will speak about atomic types, the main hardest area to understand is this memory modeling, because even if we spoke about atomics, we have the 4 memory models in modern C++. For example, we can add 2 numbers in 4 different ways if these are atomic numbers. And we must understand what are differences in these memory models, because sometimes it will give us more flexibility, more performance flexibility. But if we will just use the simplest memory models, we can also introduce the bugs in our program, in our multi-threading code. And maybe you familiar with debugging the multi-threading code and trying to reproduce the problems. It's really not the piece of cake problem. The next model will be dealing with networking, and here we will be mainly focused on Boost Azure. It's really popular library for network programming, how it can be done in asynchronous style, in asynchronous input-output. After that, a few lections about database systems, how we can dealing with relational database management system from C++, K-value, maybe even some ideas of big data frameworks. Can we, for example, do it by our hands, like the simple examples in fork join pattern? And also a few words about this object relational mapper approach, which also can be used in modern C++ language. At the end, one of the final models will be about machine learning. It's a really interesting topic for me because I have experience like C++ programming in machine learning, and also I have experience in both of them when you need to get these machine learning models, which usually train in Python, and try to apply them to make their predictions in products which are written in C++. And here we will be speaking about how this can be done, how this machine learning models and machine learning libraries can be integrated with your C++ code. At the end, we will suggest you as the final project. Here, it's mainly will be inspired maybe by your ideas. maybe your work problems or your pet projects or some ideas you want to use C++ for. And the goals for me and the course team will be just help you with it as a consultant, help you with code review, with testing, maybe with choosing the right libraries, and so on. I see the comment from the chat. Thank you, Juliana. Cool topic. I hope it will be about ML. Yeah, it's really cool one. Because maybe you all heard neural networks and machine learning will be everywhere. And will be they already in every phone, every computer, maybe not in every server, but it will be close soon. And this means what the probability what about situation in your C++ product, that sometimes your product manager comes to you and say, we have this new feature request in our C++ product, we need to introduce the machine learning in it. And you as a C++ developer will be dealing with such situation. So I also would like to present our instructor team. All of them have a lot of experience in different C++ areas. And let me highlight this additional interesting point about our course. I think it's not the good practice when you have only one lecturer on all course. Why? Because actually, with, for example, more than, I think, 10 years of experience in C++ programming, I have my own projection of this language. As Bjarne Stroustrup, the creator of C++, usually said that in C++ there hired a small language, and it's a language different for everybody. This means what, for example, I have my own projection, my colleagues have their own, and if with different lecturers you will find out how they can share their experience with you, you will maybe dealing with more objective view of modern C++ and its best practice in different kinds. So I think I talk a lot about it. Right now we have this our live stream, and also a few days after we will have this door opens day. It will be mainly focused on our ways how we teach, what elements. We'll talk about FAQs our students ask us usually. So you are welcome to join us at our next door open day. And also, if you are interested, please sign with interest testing, maybe to become the part of our new C++ developer group. I think I highlight all main elements of our learning process. The main webinars will be in online format, but you also will have the recordings. We have the home assignments, and usually we start from the C+ ones, but after a few iterations, it will become much harder and harder. Also, during the training, we will using the different chats, and you can ask questions not only on webinars, but anytime you want. Some lectures from the course team will read and answer you. And it's also, you should also understand what you need to invest your time. And this means that every week you must invest 4 academic hours, 3 calendar hours for online webinars, and about 8 hours for homework per week. But I hope this time investments will give you a great dividends after it. We are almost at the end, at the reflection stage, and I try to find out the way how I can help you to better remember the main takeaways from today's lecture. And I find ways maybe to ask you a question. Ask you a question about what you learned today. Because actually, when you just hear something, It's not the best educational experience. But if you try to answer some questions, you will try to remember what the main interesting elements and ideas and results I share with you during this open lesson. And please provide your answers using the chat. And if you can find out the answers for some of these questions, I think this means what you already learn something from today. And we are only 1 hour streaming, and it's a really good, I think, achievement if just using the 1 hour, you already not just hear something, but also learn something new for you. So please free to share your variants of answer for this question using the chat in our YouTube stream. Yeah, Juliana, thanks you also. Thanks. Also, you will be interested in different links on materials I was using for today lesson, and also here you can find the link for GitHub, and here are my fork of the original repository about Rust zero code abstractions. But in this fork, I add the C++ realization. So maybe if you are already interested, I can share it just right now using the chat. Here, almost all elements of code was written by original author Mike Barber, but in C++ bench folder, you find my own realization and benchmarks, which depends on Google benchmark framework. And you maybe can reproduce some results on your own laptops and desktops. Maybe you will achieve something new, because I usually use the just one compiler, Clang. And I think if you try some different compilers, or even sometimes different architectures, CPU architectures, you may face the little bit different results. Maybe in some cases it will be even not following this zero overhead principle here. And the main date, the start of our course. Actually, it's the new information that the first webinar will be at 27th of June, and the next our open lesson, it will be not a lesson, actually, it will be door open day. Will be spoke mainly about our course, our main ideas, the instruments we are using on our course, and asking questions for you. So please feel free to sign in and join us at the Monday on our next open event. I will be glad if you will share your ideas in a survey about our today's class. I will be sending the link in our chat. The feedback is really important for us, because the feedback is the main sources for possible ideas about what should we change, what should we keep. And I usually ask to write the both. What likes most in the open lessons? If you highlight what you like the most, it means what this part we should keep. And what you think will be not necessary, actually. We spent, for example, a lot of time on this topic, and it was not useful, and we may replace it with something in future versions. So I will be glad if you share these ideas using the survey, the link I already provided by the chat. And thank you for joining. Actually, please feel free to ask any questions. I think we are at the last stage of our open lesson, and usually the last stage is a good time for ask the different questions here. I will wait just maybe 1 minute about possible questions in the chat. . And actually, I want maybe to share with you some additional bonus slide. Usually, when I give this lesson, there was a usual question, the frequently asked question. You show us the C# and C++ results. Yeah, we discussed them already. But the original inspiration of this talk was the talk on RustConf. So the main idea maybe what the author have the Rust solution and the result of Rust benchmarks. And yeah, sure, actually there is. It's also the Java implementation, but I just decide to take the Java away from today's topic. But the Rust, the really important, interesting and important new language in programming language ecosystem. And I think we should also take a look on the Rust results for zero overhead principle. And I actually have this additional slide here. I will not show you the realization. You can take a look at the GitHub repository, but the idea almost the same. We will write the straight ahead direct index realization. Right after that, the Rust have their own iterators, and we can also use the folding techniques like the functional programming style. And also the AVX and intrinsics are also can be used in Rust. And here we see interesting result. Actually, maybe confidence intervals will be not the same, but let's, for simplicity, consider here what all solutions have the same performance, not much different, actually. This means what's interesting, Rust also, like the C++, have this idea of zero overhead principle. Not every time, actually, because I have also experienced programming in Rust, and I knew some concrete examples when Rust, which usually position himself, the community of this language position this language as for safety, not for performance, but for safety first. This target actually sometimes, not in every code, but in some code, will affect the performance of the final solution. But for example, in this problem, it shows a good result because different abstractions using just the iterators or functional style programming in Rust achieve the same result, for example, as in C++ code. It's not always, for example, direct loop a little bit worse, but AVX solution is really good. So I think it's also the interesting result, which I want to share with you at the end. And also it's a possibility for me to wait maybe for some questions. And if we are out of it, I want to thank you again for joining us today. I hope you learn something from this idea, and maybe you will in future use this recommendation how you can design your C++ code and follow this zero overhead principle, which I think the main cause for C++ to be well known as the solution for performance problems. I see the comment that everything is clear and Juliana needs to repeat the lessons. Yeah, these lessons will be also in recording in YouTube, and maybe it's also a good idea to see it one more time and read the GitHub repository to find out what the concrete solutions you can find out there. So thank you a lot. I wish you a good evening and hope to see you again. Bye-bye.